Okay, let me give you one more example, and then I will give you some practice. So this one here, here you're adding two fractions. Remember, in order to add fractions, let's say a over b plus c over d. In order to add or take away fractions, you've got to get the two denominators to be the same. So over here you would probably times top and bottom by b, and then over here times top and bottom by b, and so on. Okay, so that the two denominators will be the same. So here to add these two, well here you've got to visualize it as this bubble divided by this bubble because of this long divide line, and then over here you've got this bubble divided by this bubble. So over here to get the two denominators to be the same, at the moment the two denominators are different. So what you do is you times top and bottom here by this bubble here. So times top and bottom by x plus 2, okay, and then this here it's like it exists in a bubble, and then times top and bottom here by x plus 2 again. So this here exists in a bubble, okay, and then over here, well over here times top and bottom here by this bubble here. So x plus 4, x plus 4. Okay, this exists in a bubble here, and then here you've got x plus 4, and then this here would then become this. Hang on, it would then become this. Hang on, 3x bracket x plus 2, and then down here it would become x plus 4. This would become x plus 2. And then this fraction here will become x x times x plus 4, and then the denominator will become this and then x plus 4. In effect, the two denominators are actually the same. It's just like me saying the denominator over here is 5 and 3, and over here is 3 and 5. That the two denominators are actually the same, because 5 times 3 is the same as 3 times 5. So the denominators are actually the same, because if you look at this here, this bubble here is actually this bubble here. Okay, and then this one here is actually this bubble here. So the two denominators are actually the same. Because they're the same, we can merge the two fractions. So hang on. So this will become x. Well, you can either choose this one or this one. I'm just going to choose this side. So the denominator becomes this, x plus 2, and then at the top, let's multiply. Well, at the top it's going to be like this. 3x x plus 2, and then over here, well, because it's a plus, we take the plus down, and this will become this, and then now get this times this times this, and then this times this, and then this times this. So it becomes this. Hang on, it becomes this x plus 4 x plus 2. Okay, this is, I'm closing off the bracket here. So now it's this times this. That will be 3x squared, and then this times this here will be plus 6x, and then take the plus down. X times x will be x squared, and then x times 4 will be plus 4x. Now try and simplify here. This is like your elephant, giraffe. So merge all your elephants and giraffes together. So it becomes this. Hang on. You've got 3 elephants plus 1 elephant here. So that will be 4 elephants. Okay, and then you've got 6 giraffes plus 4 giraffes. So that will be 10 giraffes. Okay. I don't actually need it to be that long. So this one here will become x plus 4, and then x minus 2. Okay, close it off. Yeah, when you get a quadratic where you don't have a constant at the end. So for example, if you have something like 4x squared plus 10x and then plus 7, because of this 7, it makes it really hard to factorize. So if you look at this here, it's just these two terms, the x squared term and the x term. So that is actually quite simple to factorize. So it becomes this. But when you have an extra number at the end, it makes it a lot harder. But because there's no constant at the end, it's just the x squared and the x. It's actually quite easy to factorize. Take the x out because what's in common here is the x and the x here. So you can actually take the x out. Hang on. You can actually take the x out. So it's like this: 4x plus 10. Okay. And then well, yeah. So yeah. Without the number at the end, it's actually easier to factorize. So this one here, well, it stays the same. The denominator stays the same, x minus 2. And if you look at this here, what's in common here? Well, you've got a 4 here and a 10 here. The 2 is actually in common, the number 2. So you can actually take the 2 out. So it becomes this. Take the 2 out, so it becomes 2x bracket. Bracket. Hang on, bracket 2x here. Yeah, 2x here plus 5. Okay. Well, over this thing here, x plus 4, and then x minus 2. Yeah, and then close it off. When you're factorizing it, try to glance to see if any of these bubbles are the same. Here, that these two bubbles are not the same, so you can't easily kill them off. But when you factorize, try to spot to see if you can see anything that will kill each other off. So if you have two bubbles that are the same, then they will kill each other off. But here all these bubbles are different, so you just have to leave it as this. So this is your final version. Okay.